Imagine a world where every device can seamlessly communicate with each other, sharing information and executing commands in an instant. This incredible interconnectedness isn't magic, it's the science of computer networking. Whether you're surfing the web, sending a message, or streaming a movie, there's a complex sequence of processes happening in the background, allowing data to flow effortlessly across devices. In today's video, we're going to break down the exact steps that make all of this possible. If you've ever been curious about how computers, servers, and networks actually talk to each other, this is the video for you. But before we dive into these crucial steps, make sure to press the like button and subscribe to our channel. By doing so, you'll help us continue to bring you informative content and keep you up to date with the latest in tech. Now, let's get into the sequence of computer networking, starting with number 1. 1. Physical layer, the foundation. The first step in the networking sequence is the physical layer. This layer is all about the tangible, physical connections that make data transfer possible. Think of the cables, switches, and wireless signals that serve as the infrastructure of your network. This is where the actual transmission of binary data, ones and zeros, takes place. The physical layer deals with how data gets from one device to another in its raw form. It encompasses the hardware components like Ethernet cables, fiber optics, radio frequencies, and other mediums. Without this layer, there would be no way for devices to communicate, making it the backbone of any network. Data is transferred in the form of electrical signals, light pulses, or electromagnetic waves, depending on the type of medium used. For example, Ethernet cables use electrical signals, while fiber optic cables transmit data using light pulses. At this level, it's all about speed, capacity, and reliability of the connection. 2. Data link layer, establishing direct connections. Once the physical connection is in place, we move up to the data link layer. This layer establishes direct links between two devices on the same network and ensures that data can be transferred without error. It's responsible for taking raw data from the physical layer and packaging it into frames that can be transmitted. Think of it as the post office for your data organizing, labeling, and addressing each packet before sending it on its way. The data link layer also controls access to the physical layer and detects errors that may occur during transmission. It ensures that devices on the same network, like your computer and printer, can communicate directly and reliably. The two sublayers within the data link layer are the Logical Link Control, LLC, and Media Access Control, MAC. The MAC layer is responsible for controlling how devices on the network gain access to the medium and send data, while the LLC layer manages communication between devices and ensures that the data sent is correct. 3. Network layer, routing the data. Next, we arrive at the network layer, which is responsible for routing the data to its correct destination. This layer handles the movement of data between different networks, ensuring that it reaches its intended target, no matter where that target is located. It's here where the concept of IP addresses comes into play. When you send data over the internet, the network layer is what directs it from your local network to another one, possibly on the other side of the world. It determines the best path for the data to travel, using routers to forward the information across multiple networks. This process is known as packet forwarding. In the network layer, packets of data are given an address and are forwarded along the network based on their destination. The most common protocol used here is the Internet Protocol, IP, which helps guide the data from source to destination. Essentially, this is the navigation system of the network, directing traffic and ensuring data gets to the right place efficiently. 4. Transport layer, ensuring reliable delivery. The transport layer comes next, ensuring that the data is delivered accurately and in the right order. This layer provides end-to-end communication and error recovery between devices. The two key protocols at this level are Transmission Control Protocol, TCP, and User Datagram Protocol, UDP. TCP is responsible for establishing a connection between devices, managing the data transfer process, and ensuring that all packets arrive in the correct order and without errors. It guarantees that data is delivered reliably, even if it has to resend packets to correct errors. On the other hand, UDP is a faster, but less reliable, protocol often used for applications like streaming, where speed is more important than perfect accuracy. At this stage, your data is like a package being tracked to ensure it arrives at its destination in perfect condition. The transport layer manages the flow of data between two endpoints and confirms that the entire message gets through correctly. 5. Session layer. Managing connections. Moving up the chain, we have the session layer, which is responsible for managing and controlling the connections between devices. This layer establishes, maintains, and eventually terminates the communication sessions between two machines. Imagine you're having a phone call. The session layer ensures that the line is open and clear throughout the conversation, and when you're done, it closes the connection. This layer also manages any interruptions in communication, making sure that if a connection is lost, it can be re-established. In many cases, the session layer is not directly visible to users, but it plays a crucial role in ensuring that communication between devices remains seamless and that the data exchange occurs in an organized manner. 6. Presentation layer. Formatting the data. Now that the connection is established and the data is flowing, the presentation layer comes into play. This layer is responsible for translating data between the application and the network. It ensures that the data sent from one device is readable by the receiving device by handling tasks like data compression, encryption, and translation. For instance, if you're sending a message in one format, but the receiving device expects it in another, the presentation layer takes care of converting the data into a format both devices understand. It's like the translator of the network, making sure that different systems can communicate effectively. 7. Application layer. The user's gateway. Finally, we arrive at the application layer, which is the closest to the end user. This layer interacts with software applications that require network communication, such as web browsers, email clients, and file sharing programs. It's where users actually experience the benefits of the network, whether that's through browsing a website, downloading a file, or video conferencing with someone across the globe. The application layer provides protocols like HTTP for web browsing, FTP for file transfers, and SMTP for sending emails. This is where you, as the user, can directly interact with the network's services and applications. By understanding each of these layers, from the physical cables and signals all the way up to the software applications, you can see how intricate and organized computer networking truly is. Each layer depends on the one below it, working together to make modern communication possible. If this deep dive into computer networking has been helpful to you, don't forget to like this video and subscribe to the channel for more content just like this. Thanks for watching.